So until now, we created the basic structure of the circuit breaker and the cluster service to initialize Hazelcast. So the cluster service uses the config parameters that has been used for the configuration. But now we need to implement the main engine of circuit breaker, and we'll name that as the CBProcessor, and we'll have all the logic inside when to trip, when to open the circuit. And that particular class will use the parameters that have been exposed as part of the connector. For example, in this case, so now we have to leverage this values, the circuit breaker ID, the threshold percentage. So all of these parameters will be utilized now. So let's just create a class. I mean, I'll create a, I'll close this form.xml to get some space over here. Okay. So now I need to create a CB processor. So I'll do that in the internal package. Create a new class CB processor. Now this class will be used by the operations class, and the operation class will initialize the constructor. So it has some member variables. For example, circuit breaker ID that would come from that configuration of the uh, router scope. So it's circuit breaker ID. Then we name threshold percentage. So we have a value for that percentage. Then let's have a threshold period. So these are same values that the root scope will provide us. So okay, threshold period, then private string open duration, and private CB state. Now CB state won't be provided by the root scope, but we'll set this based on certain logic. Let me just get rid of compile time errors. Okay, so these are the parameters that we need. Now the first thing, let's add a logger. So private static logger should get logger CB processor dot class. Okay, it needs a static import. Logger. I'll manually add it, I guess. Okay, sul4j static org dot slf4j dot logger factory dot get logger. Okay, so I have the logger now. Now it's time to initialize the object for this class. So I'll create a constructor so that the when it's invoked from the operation class, the following parameters get initialized. So the operations class will send this parameters. So it will be circuit breaker ID, threshold percentage, threshold period, and open duration. All right. We don't need this CB state because that won't be coming from the connector, but we have to manage it on our own based on certain logic. String open duration. Yeah, now everything's good. Let me just maximize it. Okay, so I need to set the variables now. So this dot, so I want to set this instance of class, member of class. So I'll use this keyword to set circuit breaker ID equals to circuit breaker ID. This dot threshold percentage, threshold percentage, threshold period equals threshold period and open duration equals open duration. Okay, so we have now set the variable. Now we want to uh, change the state the moment this gets called, which is the starting part, right? So the state should be closed in that case, right? So what we'll do is we'll add a condition now. If we'll get the state if it's being initialized for the first time and there's no state, we'll set it to closed. And if there's some state already, then we'll return the same state. So this would happen in a scenario when you have two different nodes, okay? And in the first node, it already got initialized, but in the second node, the app was yet to be deployed. So when the app gets deployed, it should already have the same app, right? In this case, we need to make sure that the same app is deployed. So when the same app gets deployed on the next node, it obviously will have the state, right? We don't want to create a new state. It should get the state which it's already existing. It could be closed, it could be error, or it could be open. So the moment it gets deployed, it should get the existing state. So that is why we are adding this condition rather than simply returning a closed state. So if the state is not present, if it's null, we set it to closed. If it's not null, which means that there's some value, we'll return the state. So we have a method in the cluster service which can help us in getting the state. So cb cluster service dot get service instance, and through the service instance we get the state map, get cb state map, and through this we can get the circuit using the breaker ID. We can get the value. So the circuit breaker ID will be coming from the connector. So circuit breaker ID, and it should, if it's equal to null, then we'll set the state. So how to set the state? So I'll set this particular state, CB state. Set it as CB state equals to CB state dot closed. Set it as closed, and we need to add the value, updated value, right? So CB cluster service dot get service instance, because through this we get the access to the upsert method. So we get the access to upsert method, the circuit breaker ID should go same, and we'll pass the close state. So cb state dot closed. Okay, so we have set the state, and the same has been updated in the map. All right, now in case if the application is already deployed on some other node and there's new deployment going on the next node, it will obviously have a state as closed or maybe open or error. So we need to replicate the same state. So in case if it's already there, the map already has a state, we need to just return the state. It's not working. CB cluster service Okay, there seems to be something wrong. Okay, CB cluster service dot get service instance dot get CB state map dot get, and I'll get the circuit breaker ID, and this should be mapped to the CB state. So this constructor will ensure that all of these values get populated. Okay, so we have to some extent leveraged the CB cluster service class, and we are able to populate the CB state with help of that class. All right, now what we can do, we can add a get method in case if we need the state. So we'll just quickly add public CB state get CB state, and then just return the instance, return CV state. All right, so we have created a getter. We don't need a setter because that will be set by the constructor itself. So I'm not adding a setter. Now for errors, we need to increment the errors. I mean, with each transaction, in case if it fails, we need to increment the errors, and we also need to have a count of the operations. All right, so what we can do is we can create methods to basically increment the error, increment the request, increment and get the request and get the errors. Okay, so those two are important things, right? Because based on that only we can find out the ratio or the percentage. So we'll create two methods, I mean four methods. The first one is to increment error. So increment errors, increment errors. So this basically will increment the PN counter. Okay, so what I'll do is return, it has to return long value. So I already have a CB cluster service which can do this task for me. CB cluster service dot get service instance. Now once we get the service instance, we get a couple of method to access. So one is the get error counter, right? uh, Using this get error counter, so this get error counter will return me the PN counter. If I see, control click on it, it returns me map which is having a PN counter as the value, right? So what I can do is I can use compute if absent. Okay, now in this compute if absent, I'll add a key which is the circuit breaker ID, and in the mapping function I'll need to add the error count, right? So how do I get, so the idea is to increment. So we have to first get the value. Once we get the value, we have to increment the value. So we'll have to get the PN counter for this particular circuit breaker ID, which is present in the map of error counter. So how do we do that? So I'll add a function in this. So CB ID, let me name it as CB ID, and then CB cluster service. So since the CB cluster service can give me the Hazelcast instance, so get Hazelcast instance, and this Hazelcast instance will have a PN counter, and the PN counter I'll name it as error. So instead of naming it as an error over here, let's quickly create a CB constant called as error. Public static string error equals error, and let's create for requests as well, static string requests equals request. Okay, so static. Okay, so created a few constants and now let's quickly use it in this case. So it should be pn in get pn counter cb constants dot error. Okay, and let's just concatenate plus cb id. Right, so what it will do is it will create error plus the CBID. For example, error demo app CB demo apps. So it will create that particular PN counter, and in case if it is not there, it will create, and if it is already there, it will just increment. So what we are going to do is dot increment and get. Okay, so we have incremented and we get the value. So in this manner, the error counter can be incremented and retrieved. But it's giving us some error. So cannot convert from PN counter to long. So what we are getting is a PN counter and we have to compute it to long. So possibly there should be some mistake. So this is a function get Hazelcast. So it appears that this will return. So the compute if absent will not return, this will return PN counter because the value that we are adding, it will return it. So it's not over here what we need to add. We need to move it outside the compute if absent. And now we get the counter. We increment it and then we get the counter. Okay, so this is fine. Now on similar lines we need to increment the request as well. So we'll create a method to increment. I'll just instead copy and paste it because it's the same thing. We just need to refactor this method slightly. So increment errors should become increment requests, and error counter becomes request counter, and then we change the CB constants error to requests, and that's pretty much there's no change. Yeah, so we have this two counters, error counter and the request counters. Now if someone wants to get the errors or the request counter, we can create another method which is public long get errors, and this should return the error. So what I'll do is return, let's again call the cluster service dot get hazelcast instance dot get pn counter, and in the pn counter we'll have cb constants. We pass this constants dot error, but it's not just the error. While setting, we are setting error plus the circuit breaker ID. So circuit breaker ID can be retrieved from the class member, and then we can call get. So it returns me a long value. Okay, next. is for request. So let's refactor this and make it as get requests. And let's change this error to requests. Yeah, that's all. So this is using this method we can increment, using this method we can increment request, and using this get the errors and get the requests. I mean the count from the PN counter. Okay, so we have few utility methods ready for us to use. Now it's time to add the main logic. Now we have two methods to add. One is to handle the closed state. So in case if there is a closed state and there occurs error, we need to handle it, right? So what is the idea? Uh, the state was enclosed. The first error occur, which we are counting as an error. So the first error occurs. Now, when the first error occurs, we'll immediately change the state to error state because now it's closed, but it's closed with errors. So the state will change to error, and what we'll do is we'll start a scheduler. So that scheduler will start from the point when it's supposed to start. For example, the error occurred at 10 a.m. and the threshold period was like 10 minutes. So after 10 minutes from the first error, the schedule should get triggered to check if the ratio has been met or not. So in case if the ratio has been met, it has to trip. If it's not met, it will not trip. All right. So that is what we need to implement. So let's quickly implement that. So I'll create a method public synchronized void and name it as closed state error handler. Now there's a point to note. The reason why I have created it as synchronized because I want it to be thread safe. There could be multiple simultaneous calls, and uh, it will trigger this method parallelly. So in that case, there will be mismatch with the count. So we want only one thread. When one thread enters, it locks this method, and once it's complete, only then it should allow other methods to allow other threads to use it. So we basically want to avoid race condition because that would lead to an inconsistent state of the circuit breaker, which is not good. So that's the reason it's synchronized. Now this method will be directly called from the operations class. So in the operations class, uh, I have to use this callback, which I haven't used yet. But when I use it, I should ensure that any errors that occur should, even if it occurs, it should allow the callback to be called. Because in case if the error occurs and the callback is missed out, the request goes to infinite loop and it will never respond back the way we saw in this request, right? It didn't get any response and it was just lost somewhere. So what I'll have to do is I'll have to add a try catch block, and in catch I'll just log so that the control can be sent back and uh, the callback can be called. Or instead we have multiple options. Now we can also send this callback object to this processor, and in catch I can do callback.success. But let's handle the callback in operations class itself rather than adding that complexity over here. So I'll just add a catch block, and this catch block can catch any error. So let me use a parent throwable. So throwable, and I'll basically just log and then return the control if any error occurs so that the callback can be done. So in this case, I have the logger. So logger.error. So what I'll do is I'll write some meaningful log. Failure occurred while handling error in closed state. So I need to do is throwable dot get message, and let's print the throwable itself. Throwable. It will call the toString method on throwable. Okay, so we have handled it. Now we need to write the actual code. So let's first start with the logger. So this will be called when of error occurs, when the first error occurs. So let's log info and let's log errors detected, error counter will be increased and state will be changed to error, and but the current state would be closed by this time. Current state is closed. Okay, then we need to increment the errors. So long error count is equals to increment error. So the moment we created this method, right, increment errors. So the idea is that this particular constructor would be called first before any of these things occur. So it will have the circuit breaker ID. So we are just calling the increment errors, and increment errors will get the class member circuit breaker ID, and accordingly it will get the errors if it's there. If it's not, it will start from zero and then increment it. So that's the idea. So once the increments errors are incremented, we also need to increment the request count. Mm. So, but first let's log it because we'll be running it for the first time. So we need some logs to check if it working properly or not. So later on we can move it to debug mode, let the logging level, but let's keep it as info for now. So updated error count, updated error count, then let me add the error count. Okay, so that's done. Now same way I have to increment request. So long request count equals increment requests, and logger.info updated request counts. Request count. Okay, so we have these two things log, and now we have to change the state, right? We incremented the errors, we incremented the request. Now it's time to change the state. So CB cluster service dot get service instance dot upsert CB state map entries will pass the circuit breaker ID and will pass the state. So the state will be now error because we encountered error. So so that's it. So we changed the error state, but now we want to monitor, right? So after the threshold period uh, is attained, we need to run a schedule. So basically we need to have a runnable, and that's the reason we created a method, right? If this is the method that we created to schedule tasks, so we need to use that method. So for that to happen, I'll have to create a runnable. So what I'll do is I'll create a new class. So rather than there are two options. We can either create an inner class which can be directly accessed, or we can create a fresh new class in a new package, which I would rather prefer to do to keep things clean. So what I'll do is I'll add a tasks package, and in that I'll create a task. So let's create a tasks pack. Okay, com.resiliency.connectors dot tasks. So in this tasks, let me create a task which is to trip the circuit. So I'll create a class and name it as trip circuit task. So this is the task that can trip the circuit, and this particular task has to be runnable, right? Because this takes in a runnable. So I'll implement runnable, implements runnable. And the next thing, this task will be moved from one JVM to another JVM by Hazelcast. So when such things happen, the object gets transferred. It needs to be serialized and then deserialized. So let me implement serializable as well. Control Shift O, import serializable from Java IO package. Now we need to implement the unimplemented methods. So, okay. Serializable is a marker interface. It doesn't have any method to be implemented. So if you see, it's an interface with no methods. And it's a marker interface, which means that the JVM will handle it. So we don't need to worry about it. Okay, so that's the reason we are only overriding only one method, which is the run method. We're implementing it basically. So in this run method, we'll come to it later on. But now let's add some details to this. So again, this particular class, it's complaining about something. So I think it wants a serial UID. Okay, so let's add a serial version ID. So that will be used for serialization and deserialization. So I hope that's auto-generated value that we are using. Now let me quickly add a logger over here as well. Static final logger equals get logger. I'll name this class trip circuit task dot class. Now what I can do is I'll just copy the imports so that the other classes logger. Okay, so now we get rid of the compile time errors. Next up we have is we again need to have the same variables. So I'll need to have a circuit breaker ID. So I'll create a circuit breaker ID. Circuit breaker ID, then threshold percentage. Now this is something we'll calculate. So let's create a variable threshold percentage. The value will be big decimal percentage. Then, okay, this is a wrapper. So I need to import this java.math big decimal. Okay, then what we need to add is the open duration, private string, open duration, and then we have to add requests and the errors. So we need these variables. Now we'll use them. So again, to initialize this variable, let's use a constructor, public trip. So this will be sent from the CBProcessor class. So all this value will be, while initializing this constructor, uh, the CBProcessor class will send it. So trip circuit task. Okay. Now let me just add a few fields. So I'll add string circuit breaker ID, big decimal, threshold percentage, open duration. I don't. Uh, I'll add requests. Then I'll add errors, and okay, let me add this open duration as well. I'll send it from the processor. Okay, so all this will be initialized, and now I need to assign this value to the class member. So circuit breaker ID equals to this dot threshold percentage equals to threshold. So threshold percentage will come from the connector to the processor, then through the processor to this uh, task. So then we have open duration requests. Let's get the request, this dot requests, this dot errors equals errors, and this dot open duration equals open duration. So open duration will also be retrieved from the connector itself. Okay, so things are good now. Yeah. So next up is we have to add the logic to this run. So when the task gets created, what it should really do. So it should first check the threshold. So when the threshold period expires, right? For example, first error occurred at 10, it went to error state. Now at 10:10, because threshold period was 10:10, 10 minutes for this error. So after the 10 minutes have passed, it should calculate the ratio. And in case if the ratio multiplied by 100, which becomes percentage, if this percentage is greater than the specified percentage, it should trip the circuit. So tripping is basically changing the state to open. So that is exactly what we are going to do now. So what we do over here is we make get a big decimal ratio. Okay, ratio equals to new big decimal, and so new big decimal will have errors. So this errors, I'll divide this errors by the number of requests. So that will give me the ratio, right? So I'll divide by another new big decimal, and this is the number of requests. So errors divided by request gives the ratio, multiply by 100 gives the percentage. So let's quickly log a few things. Logger.info error count, errors, logger.info. I'm just adding this for understanding purpose. We'll later on move it to the debug level, because this is the first time we are developing it and there are chances some things might go wrong. So to be able to quickly debug, we need some verbose logging over here. So let's info, then let's add a ratio. What's the ratio that got generated? And okay, so this is the ratio. And then final some useful log, which is this will always stay in will just multiply by 100. So I think we don't need this. Let's just remove this. And what I'll do is now add an if condition. So in this if condition, what we'll do is we'll compare this ratio dot compare to. Now in this compare to, I'll do threshold percentage dot divide. So what I'm doing is I'm converting that percentage into decimal value. So I'll divide that by 100. So new big, so I could either multiply the ratio by 100 or divide the percentage by 100. That gives me the same effect, right? So new big decimal, okay, new big decimal 100. Now this needs to be compared, right? So ratio dot compare to, and then here is the compare. Okay, now this has to be compared with. So now compare is like if the I mean the ratio is less than the defined value, it will always be uh, greater than or equal to 1. So that is how the compare will work. So if we hover over this compare to, it shows that compares this big decimal with specified big decimal. So two big decimal objects that are equal in value but have different scale are considered equal by this method. But let's check the returns. Okay, it returns -1, 0 or 1 as the big decimal is numerically less than. If it is less than, it returns -1. If it is equal to, it returns 0. And if it is greater than value, it returns 1. Okay, so the ratio, if that was counted, and uh, if it's less than the defined threshold percentage, will obviously get -1 or 0 if it's equal to, right? So now we have set if it's greater than 1, which means the ratio is greater. In that case, what we'll do is we will close back the circuit. So CB cluster service dot get service instance dot absurd. Circuit breaker ID is already there. State will pass as closed because we want to, because the ratio that was calculated was less than what has been defined. So cv state dot closed. This is what we are going to update with, and let's just add a logger.info. So what we'll print over here is error ratio is less than the defined threshold. So if it's less than the defined threshold, we move the state back to closed. State will be changed back to closed. All right, so we have made it as closed. Now once we close it, we also print logger.info circuit state changed to closed. Now we need to reset the error count as well, right? Because since we are closing the circuit breaker state, it now needs to start fresh, because then if we change it to close and we keep the counter as is, then we'll get inconsistent value. So let's just reset. So add another logger, info, and let's resetting errors and request count. Okay, now once this is done, CB cluster service. So we have methods, right, to do that. Get Hazelcast instance dot get PN counter, and in get PN counter we want for one for error. So CB constants dot error concat with the circuit breaker ID, and then destroy this. Similarly, we'll do for the requests. So both PN counters are now destroyed, and then logger.info reset completed. All right, so this is done. But in case if it's the otherwise, so what we need to do is we need to open the circuit. So what we do, logger.info print errors exceeded the defined threshold. Circuit will now be open. Be opened. So let's open the circuit and CB cluster service dot get service instance dot upsert method, because we want to upsert, and state should be open. CB state dot open. Okay, and then add a log circuit state changed to open. So that's done now. So we have opened the state. So, but when we open the state, it has to go back to closed, right? At some point of time. So again, we need to schedule another task, which should be to restore the circuit, right? In this case. So what we'll do, we'll create another task, which is to restore the circuit. So let's create another runnable, which we'll call it as restore circuit. All right, restore circuit task. And even in this class, we'll add similar logic, but now we don't want additional detail. For this we only want the circuit breaker ID. It will just open the circuit. It doesn't need to calculate any error ratio or anything. It just needs to uh, just close the open the circuit. So what we can do is we can have private string, and this should have circuit breaker ID. Okay, and this circuit breaker ID will be provided by the constructor. So I'll create a public restore circuit task and circuit breaker ID, and this dot equals circuit breaker ID. Okay, so we have initialized this, and now we want to uh, make it runnable. So let's implement runnable and serializable. Add unimplemented methods, import serializable, then add serial version ID. Shall add a logger. Let's add a logger. I'll copy from here, paste it in here, name it as this, Control Shift O. Okay, so we have now the run method, and this run method, what I want to do is change the state back to close. So logger.info, trip duration completed, restoring the circuit. So the circuit is now being changed to closed. So let's use CB cluster service dot get service instance. Then we get upsert CB state and the circuit breaker ID and CB state dot closed. So it's closed now. Okay, and let's add a logger.info. In this info, what we'll print is circuit restored to closed state. Closed state. Okay, but once it's restored to closed state, in case if there is any counters lying around, we need to reset those. So CB. So now to reset, we can use I think we should use the same logic which has been used in the trip circuit for removing, or instead what I'll do is let's create a utility class and we'll have this redundant logic. I mean, because since we have to, instead of writing it multiple times, let's let's create a utility package, and over there I'll add everything. So new package com dot resiliency dot connectors dot utility. So this will, okay, there already exists a utility package. All right. So, okay, sorry, there is a CB constant in this. So what I'll do, I'll create a class called as CB utility, and I'll have all my methods over here. So in this utility class, I'll create a reset PN counter, and so that I can reuse it. So public, so utility class should have all the methods as static because we don't want to instantiate, we just want to use the name and get access. So reset PN counter, reset PN counter, send the PN counter. Someone has to send the PN counter, only then we can reset, right? So PN counter, PN counter, Control Shift O. Okay, it's not able to resolve. Let's see. There it is. Okay, so if the PN counter is not null, otherwise we'll get null pointer exception. If it's not null, then we just destroy it. And we print logger. I don't have a logger. Let me add a logger over here. cbutility.class logger.info. Should I what to add is I'll add destroying PN counter. Logger.info PN counter destroyed. Okay, so let's use this utility method. So let's call CBUtility dot reset PN counter. We need to pass the counter. So CB cluster service will help us in getting the service instance, which in turn will help us in getting the error counter. And from the error counter, we just remove, we have the map, right? So we remove the circuit breaker ID and that will give us PN counter. Similarly, let's do that for the request. So get request counter. And now we'll use the same thing rather than doing that overhead over here. Just remove, just reset this counters. Now it's good. Okay, so we have pretty much done the restore part and the uh, trip part. Yes. Now let's do Control Shift O. This is not required. Let's remove this. Okay, and I see one complaint. Okay, this open duration is not used. Okay, we need to use this. So in the scheduler, uh, we are sending it. Okay, but to restore, right? When we want to restore, we'll have to pass this open duration. So uh, we also, okay, let's just call this CB cluster service. CB cluster service dot schedule task will provide new runnable. So this restore circuit task, circuit breaker ID, and the delay. So the delay will be open duration, how long the circuit has to be opened. Okay, so when this task is being called, it will check if the ratio is less than the threshold, it will move back to the closed state. In case if the ratio exceeds the threshold, it will open the task. And the moment it opens, it starts another task. It schedules another task to be triggered after the open duration, which will basically close the circuit, right? And this is done by this restore circuit task. So yeah, that's pretty much for this trip circuit and restore circuit task. And we also created a utility class at this point of time. Now let's go back to the CB processor and continue that part. So in this CB processor, in the closed state error handler, right now we have to schedule a task over here to now it's in error state, right? So we have to schedule and check that after the given threshold for the error period, did it cross the limit or not. So for that, we'll use the trip circuit task. So what we can do is, let's add a logger. After the upsert, let's instead create a trip circuit task. So we'll create this task, trip circuit, or else write trip task. New trip circuit task. Circuit breaker ID. We'll move on from here. Threshold has to be threshold percentage in big decimal. So the threshold percentage we have is in string. So I'll do new big decimal. Now the requests, I'll use get requests, number of requests. Errors, I'll use get errors. Open duration will be open duration. Okay, so next, what we want to do is we need to schedule this task. So CB cluster service dot schedule task trip task. This is the runnable that we want to send and the threshold period. So it takes two arguments. One is runnable and is the delay duration. So delay, it has to, this task has to become active after the threshold period has crossed. And once this is done, logger.info task scheduled error check. Okay, so the close state error handler is completed. Now let's check the error state error handler. So let's create this error state error handler. Same thing. I'll copy this stub and just refactor it and name it as error state error handler. So now when the circuit is already in error state and the requests are coming, what to do? We won't do anything much. We'll just increment the error, increment the requests. That's it. So that the schedule that runs will be able to get some conclusion. So long error count. Okay, long error count equals increment errors and long request count request request count equals increment requests. And let's just add some log. So this part will be called when the circuit is already in error state, and then it will just keep on incrementing the errors and requests so that when the schedule gets triggered, it will get the latest count of these errors. So errors detected, error counter will be increased, and current state is error. And then let's print the error count. Let me just copy this. Okay, and fail. This needs to be changed. Error state. So yeah, we these are the two methods that we needed. For open, we don't need any method because open does nothing. It just you have to give your own logic in the open state, but the closed state has to do this over closed and the error state. So that is why we have this two methods. So having done this, we have pretty much, I mean, almost on the verge of completing the circuit breaker, because we have created the main engine now. Now what needs to be done is just add logic in the operations file to route to a particular, we have two routes, right? Main route and fallback. So to route the messages to fallback or to close route, that decision has to be made over here. And also we need to evaluate this error expression. So this is the only thing which is pending now, and we'll try to figure that out in the next video. So I hope until now you have got a quite good understanding of what we have done. Thanks for watching.